Hi everyone, nice to meet you. Nice seeing you back here. Today we'll be speaking on kernel conquest, breaking boundaries and demystifying kernel SU for root access in Azure Cloud Shell. Here's a brief about me, myself and my friend Abhishek. Abhishek here is the software developer at Nokia, and his primary area of research is cloud security, kernel exploitations, and bug bounty programs. He's been really up to it this year, including CV 2025 code. Interesting. It is actually a very interesting bug class, speculative store bypass. He's also alumni of Team BIOS. I'm seeing a lot of people from Team BIOS. Cheer for Team BIOS. He's also a CTF player and an MSRC Q3 2024 leaderboard. I'm Vamsi. I'm a researcher from Indian Institute of Science, and my area of research would be ML for cybersecurity and AI-driven risk scoring. This is the background of what we are going to be covering today. First, we'll be answering some questions about Azure Cloud Shells, and then we'll be diving a little bit deeper into the cloud architecture, etc. Then we'll be analyzing the root cause and the flaws and how we can come up with the mitigation strategies. We'll be also having a recorded demo, and we'll be learning how it can be mitigated. First of all, how many of you worked with Azure Cloud Shell here? Anyone? Yeah. So you might be knowing, like, how much time does a cloud session last before it times out? Inactive cloud session. So actually by default, it only lasts for about 20 minutes, after which the session is deleted. So all the files which are stored in the drive would be saved, but if it's not saved, I guess we'll be risk losing the data. And about 20 concurrent users we have per session. And the interesting question would be actually whether we have root access in Azure Cloud. We'll be discussing that further. So here is a brief background about Azure, for those of you who don't know. Azure is an interactive, authenticated, browser-accessible terminal which manages Azure resources. So it's basically a user-friendly terminal there. So Azure Shell provides authenticated, pre-configured environments which you can directly access through your browser, and it's completely managed by Microsoft. Let's talk about Cloud Shells, right? Azure Cloud Shell actually runs on Azure Linux, specifically container. So Microsoft distribution for cloud infrastructure uses these resources. So as we can see, this is before the exploit, the kernel version and information. It's been since updated. So here I guess it's important to understand that the Cloud Shell container does not have any outbound network access. So diving a bit deeper, it's important to understand that a container is not a VM. So it's not equal to a VM. So a container shares its resources with the kernel host, but whereas a VM itself owns all the resources and C groups. Here is the baseline information about the security profile. As we can see, there are different categories for the product management tools, host access, etc. Since the bug was actually reported, updated user guidance report was updated by MSRC. In this, the brief would be, now the instance of the Cloud Shell runs on the isolated VM. No other instances will be sharing the same VM. Also, the user data is stored outside the container. So what happens is the VMs are not reused. In the event of a vulnerability allowing the user to escape the container, there's no exposure to the user data. So a container cannot be considered as a security boundary as of now. So coming back to the question I had asked, does Azure Cloud give root access to the user? The answer is no. actually, it runs on an unprivileged mode. I can actually show it to you. Give me a second. Okay. We can come back to this then. We had discovered two vulnerabilities and we had reported them to MSRC. They are as follows. The first one is Open vSwitch integer manipulation vulnerability. This was given an escalation of privilege and it was an important severity. So here what it gave us was out of bound privilege, write privilege, escalation in Open vSwitch kernel module. And the second vulnerability that was discussed with MSRC was NF tables after free. This was a moderate level severity. Here, in brief, the discussion would be around dangling pointer in the same transaction unit creates a use after free condition. This grants the attackers potential access to unauthorized access and control over the system. Abhishek will continue.
So, thank you, Vamsi. That was a good brief introduction about Azure Cloud Shell. So, let's deep dive into the root cause of flaws and its analysis. So, how many of you have worked on Netfilters? So, what actually is a Netfilter? Any of you? Okay. So, Netfilter is basically a packet filtering framework which mainly classifies and it basically uses NAT and firewalling. So, what exactly we are trying to show you is the Netfilter path traversal. So, how actually it works? So, a user presently sends a packet inbound network having a configuration of IPv6 and IPv4. So, when a packet is first set, he does a pre-routing hook. So, what is a hook here? It is a specific point in the networking stack. So, Netfilter tables and chains are being used here. User can modify his own Netfilter chains and tables. Then further, we are doing a pre-routing hook, which forwards the packet, and the decision routing is being made here by the routing algorithm. That in turn goes to the kernel Netfilter hooks. After that, and another pre-routed and post-routed outbound networks are inputted towards the socket output routing. So let's consider a case where a socket file is being inputted to a server. So we use APIs these days. So many of these APIs aren't that secure. All of these APIs have open ports. So that was a similar case which happened here. So this is a basic overview of what actually is present and what components are present inside the Netfilter as an NF table. So we are having an inter-process communication between the user space and the kernel space. So we have few components, which is batch start. So we are initializing a process by creating a structure node and declaring all the parameters. I'll show more on the next slides. So we have a few more key concepts like new table, new chain, then new rule, and the deletion rule. So this is basically an inter-process communication between the user space and the kernel space. So let's deep dive more on the technical aspects. So the main flaw, what we have looked at, is an improper reference counting. So let me take an example. What if we have a network stack and we have a set S, let's name it set S, and a chain C. What if E expires before and is skipped before leading to an incurrent reference count? So what I mean is, if a network stack is present here, an element E is expired before actually updating the reference count. What do we get? We have a invalid memory access present there, and which leads to an UAF vulnerability, use after free. Mainly, we are doing this in the abort phase. So I'll walk you through the three phases: the prepare, the commit, and the release phase. So what exactly happens at the prepare phase? So the kernel initially scans all the packets which are unbounded. Here I've just taken a single packet but in reality we have millions of packets flowing through the kernel module. So we are stepping into a system where a removal of chains are happening, and these are mainly present in the network stack. So in the commit phase, what we are trying to do is we are doing a walkthrough, and we are determining what action needs to be done, what allocation will we do, what memory allocations are being doing. And in the release phase, finally we'll be doing a cleanup, and we are looking at the error handling, how the reference count and invalid memory access can lead to an use after free vulnerability and leads to a dangling pointer. So this is a visual representation of what I've spoke in the previous slide. So initially on transaction prepare phase, then we have a commit phase where a reference count is not being valid in the kernel module. So this is basically in the Netfilter API itself, api.c file. So we get a transaction abort. And to be precise here, we need to look at the buffer stack. So if we oversize the buffer stack, again, kernel will give a warning telling that you have entered a malformed packets and it exceeds the limit. So let's go each phase by phase. So we have few components, steps, initialize transaction. So firstly, if you look at the code, here we're trying to allocate. So firstly, we're trying to do a structure. We're creating a structure of a message type. Then the key action here is we're allocating memory. Then we are going to validate the input. So how is this being done? We are checking if the value is equal to null. Then we are passing it to an invalid state. So this point at the initial testing, we were not able to leak the exact commit credentials in the kernel itself. So what we try to do is we try to do a reverse engineering, get the null pointer dereference value and break points, then go on. So this was entirely in a queue transaction. So we have added a transaction list pending to a commit list. So if you look at the code for new objects, set initial state or activate preparation. Here we are doing a message type. We are looking at the message type and we are trying to increment it in the form of a linked list, and we are going to activate a new table. Users can create their own, modify their own user tables, the new chains and the deletion rules. So here we are also setting up an object state. Why is this important? So suppose let's take a transaction phase which has already existed. So here we're trying to do an expiration earlier before the deletion happening. So we are using a concept of RCU, read, copy and update. So in the commit phase analysis, the red colored code is the main important part. Here we are traversing the commit list. So what we're trying to do is we're looking at the error handling, whether if it is able to really do a reference count. So here we are performing certain operations like let's perform a create, update, or update the objects or delete object, like an RCU. Then we are trying to activate a new objects and deactivate the old entry which is already present in the entry list in a form of a transaction queue. Then we also have written a small piece of code where we would like to log and audit the changes, which will help us in further research. And this is an ongoing research presently. And in the release phase, we are presently trying to free the memory and all the resources in itself. Then we are going to call Netfilter, the NF table transaction destroy. And we are traversing all the commit list again. Here we are decreasing the reference count in a ascending order. So let's take 10, 9, 8 and let's decrease it. And from the below, let's take -1, -2, -3, that way. So when the reference count is being deleted, the increment count obviously gets into a invalid state. So we can't have packets in a negative value. That is missing in the error handling. The code is not able to validate the negative value present in the packets. So there's no proper error handling being done here. And finally, we are doing the removal of the commit list and we're deleting the read, copy and update. So let's discuss the main vulnerability. So this is a piece of code which I've taken officially from the Linux in itself, the foundation, Linux Foundation. So this is a piece of code in the Netfilter API.c. It's a file you can do a research. So this code is mainly responsible for deactivating and unbinding the NFT table set in itself. So here, if you look deeper, there's a switch case being used. So an NFT transaction prepare error is not able to deactivate and update the element and update the reference count. So if the flag is set anonymous and it performs an additional cleanup, then we can get a dangling pointer and access the invalid state. So the issue is mainly when the transaction fails at this point, a Netfilter transaction prepare is not able to validate the reference count and it is being decremented. So if the reference count is reached to 0, then we will have severe cases where the memory can be freed and we can leak certain data. So however, this function is not yet updated. So when you see the binding list present there in the next case sensitive NFT transaction prepare, we are doing a mapping function is being used here. We are trying to deactivate the reference count and the memory is set freed and potentially we are leading to a UAF vulnerability. So this is the basic overview of our exploit chain. So we are starting with a batch initialization, setting up all the structure, the NF hooks, everything. Then we are doing a set allocation. We have taken a memory of 64 bits here. I tried taking 128, but it didn't support. The kernel version was very low. And we are trying to do a set release. So here we have taken a set S and we have associated it with specific tables, chains, etc. And since the set is not properly deactivated, the memory can be freed. And we are finally doing a syscall and I'll show you the demo. So this is the before the exploit time and the version is about 5.1.102 if I recall. So 5.10 1.0 underlying host details. So let's see the exploit. So I'm just doing an initial ID, checking I'm an unprivileged user. So I'm running the exploit. So we get a root shell. So this was the open vSwitch integer manipulation. Then in the second one, the NF table use after free vulnerability, we are able to leak the heap address as well as the KSLR bypass. So again, we get a root access here. So the main fix by MSRC is quite interesting. So as a defense in depth, yes, MSRC is very critical in handling these bugs. And we have reported and we have followed the CVD procedure with them. So as a fix, they are releasing an updated kernel version, which is latest, and the fix has been completed. So we actually thought of showing a live demo, but MSRC is clever. They have fixed it. And the existing security controls by MSRC is very interesting. They have a container. So they say the container boundary is not assumed to be inescapable. So we can get container escapes, but it is ensured by design that container boundary cannot have a cross-tenant accounts. So we'll have escapes only in the user shell, meaning a user session. So we can't escape into any other sessions. But this is debatable. What if we have open ports? We can cross-tenant it. And we need to also bypass Hyper-V. That is out of black box nature, which we need to do more research. And finally, the impact stated by MSRC is we have a single user execution environment. So Cloudshell is a single user execution shell. When a user elevates as root, they will only be able to access resources present in their own user session. Cloudshell is designed in such a way that container escapes is restricted and user sessions does not compromise other tenants. And this statement was given after the fix. And let's discuss some conclusions and key takeaways. Before that, I would like to show you a few mitigations which MSRC has recently implemented. Some kind of hardenings. So I'm just connecting it to the Cloudshell. So the first thing, they have updated the kernel version, which is latest. So Jan 14th. Then if you do a sudo -l, they have stated clearly that we have no new privileges. User can't use root at all. And no new privilege can come up. So if you want to see this more, we can go into the status. So here there are certain container capabilities which it is default in Linux, and MSRC has enabled a flag param. This is also escapable. I'm trying to do a present research on this. Any questions? So a few key takeaways which I would like to tell you. Container security is very crucial. Even though whatever isolation layers we have currently in the market, like NSJail, Hyper-V, they are escapable. So we need something new technologies which are not present. Even though they're new, they can be exploited. And security is a team sport, which I would like to tell. And few configurations is when there's no root access by default, let's break it. Let's try to get root access. And sandboxes aren't foolproof. So we can do a container escape, get the main host. So thank you.
Guys, if anybody is having any questions to the speaker, you can definitely ask them. We can take a couple of questions. Yes, please.
Thank you. Quick question. The changes that you're doing to the rules is just a...
Can you keep...
is it better now? Yeah. So the exploit is working because you're sending a specific packets to change the rules, or are you doing an IP tables? The commits are to the IP table rules, or is it a user traffic that you're sending?
It's user traffic.
Hey Abhishek, hi, Dhaval this side. Interesting find, please bear with my voice. So I have two questions. Number one, what prompted you to, go into research at this level? Is it an accidental discovery, or you were focusing on something which is actually specific to containers? And a follow-up to that, please go ahead.
Yeah, sorry. So that's interesting. I myself wanted to install a new tool in Cloudshell. Like I followed BOYD, bring your own device. I didn't have any VMware setup. So I wanted to install a new package, but I couldn't install any package in Cloudshell. We required root. So I was like, let's break into root and install.
Awesome. That's great. Follow-up to that. Have you tried exploring this on other platforms as well, beyond Azure, maybe Google?
Yes, but Google does have root access by default.
Okay.
We need to break out of the container.
Yes.
They have K8s presently running in their C groups. So we need to do a further investigation.
Great. Thank you so much. Great.
Thank you. Thank you.
Anyone else? Yes.
Sorry.
Anybody at that side also? So after this, we can take a last question.
Mm-hmm.
Hi, did you try it in OpenShift or OpenStack containers?
Sorry, can you be loud?
Did you try a root privilege escalation in OpenStack and OpenShift containers?
No, I didn't try.
Thank you.
The success rate of this exploit was 7 by 10. It works on few kernel versions. I did give a try in kernel CTF by Google. It worked.
Yeah. Hi, Ankit here. So you have told Google gave by default root access, and here you got the root access.
Yeah.
So what make any difference here? Anyways, you become root here, you can install, and Google is already giving this facility. So by default, Google is vulnerable in that case. So how these organizations are defending themselves? Like, okay, we are giving you root access, or you become root, still it will not create any problem. You said you cannot go to the other tenant's account because there is no open ports and all. But as you told, still you can go via some other mechanism. So why this kind of vulnerability is not publicly debatable or discussed, or anything you find out? Okay, giving a root access can create more problem.
Yeah,
Because Google, I know very well, their their tactics are little different. First they give a vulnerable protect and then they fix and they do like this. I should not say, but I personally observe. So that's how it happens.
we are not here to debate about Google and Microsoft.
Maybe
So-
the target audience requires some specific functionality, so that's probably why.
Okay, because it was quite interesting for me. Like Google is giving by default root, but still it is working very well and everybody is using it. So you guys try to break it anytime in the Google side?
No, we haven't.
Okay, so what wrong Microsoft did with you guys? So
They just they didn't follow. Probably
okay.
they were outdated. The kernel version was outdated.
Okay.
So during the time of exploit in 2024, which I tried, the kernel version was outdated. But they did have good restrictions. They did a good job.
Okay. Anything you are finding out in AWS or any current research is going on?
Yeah, security misconfigurations, AWS bucket lists, SSRC. We can try in AWS. I'm presently working on it.
Okay. Thank you.
Thank
a
you.
lot.
Okay, that's all. Okay. Thanks a lot, Abhishek and Krishna. That was really a good informative session.